Back in 2017, Google Play announced that in August of this year, all new and updated apps that include 32-bit native libraries must provide corresponding 64-bit versions. Providing 64-bit versions of native code generally improves app performance, makes way for future innovation, and sets your app up to work with devices with 64-bit only hardware. We've supported 64-bit CPUs since Android 5.0 Lollipop back in 2014, and we've been updating development tools and changing the way distribution works on Google Play to help you support 64-bit in your app. First of all, the APK Analyzer in Android Studio can help you find out if your app contains native code. Android native code is distributed in shared object dynamic library files with the .so extension. The APK format requires that these .so files sit within the lib folder in subfolders named for their target application binary interface, or ABI. If your APK has an Army ABI, Army ABI-V7A, or x86 ABI folder, it means your app has 32-bit native components. If you're building these libraries along with your app, the first step is to see if they'll build in 64-bit. In Gradle, you can build in 64-bit by adding the 64-bit variants to the ndk.abi filter setting. When using CMake, building a 64-bit artifact involves defining the appropriate Android_ABI value. If you aren't building the library yourself, there's a good chance that the library developer is already providing a 64-bit pre-built artifact. Most Android games are written using game engines that utilize native code. Many of these game engines now support 64-bit on Android. Since Unity only began supporting 64-bit on Android recently, Google Play will continue to accept 32-bit only updates to existing games that use Unity 5.6.7 or older until August 2021. That being said, upgrading to a 64-bit compliant version of Unity is highly recommended, and Unity provides guides to help you do this. If your library hasn't yet been built for a 64-bit system, you will need to update code that assumes pointers can fit in types, such as int, unsigned, or uint32_t. Use the intention-revealing types uintptr_t or intptr_t instead, and the ptrdiff_t type to store the difference between two pointers. Use the following compiler flags to catch cases where your code is incorrectly converting between pointers and integers. Other areas to address include correctness of format specifiers in printf or scanf-like functions, implicit functions returning pointers, hard-coded type sizes, and inline assembly code. The simplest way to publish a 64-bit version of your app is to add the additional 64-bit library to your APK. However, this will make your APK larger, perhaps significantly larger. Anticipating this, we created the Android App Bundle, Android's new official publishing format. When published with an app bundle, Google Play will make sure that only the necessary libraries are downloaded for each specific device. App bundles can also be used for on-demand feature delivery, instant experiences, and more. The best thing is that switching to app bundles requires no changes to your app or game, and is supported in Android Studio 3.2 or later, Unity 2018.3 and 2017.4.17, and Cocos Creator 2.0.9 or later. For those of you who are already supporting 64-bit, thank you. For more information on writing your app for 64-bit, check out the links in the description.